Hello, hello. Hello. Audio works. Okay, so welcome back. Uh, I want to continue from where I left off 2 hours ago. Um, just give me a moment to get started. I want to make some coffee though. Okay. So, where did I stop? I can open my screen. Hello, everyone. Welcome back to the stream. This is the 7th stream of the, well, if you count that, I mean, with the interruption, it's kind of the continuation of the 6th stream. But let's say that this is the 7th stream, because this is going to be the 7th video anyway. So yeah, in the past stream today, I added some color from hex at compile time, calculating the vector 0 to 1 from a hex color. Then I added STB image. I did not find a zigified version, but I just used C directly. Can I do this? I can. Used C STB image directly. Okay, and then I loaded textures into buffer with STB load. And well, I created an OpenGL texture buffer, but somehow it doesn't work. So I want to debug and see what's going on and try to figure out where I'm making a mistake. By the way, oh, hello Loms, nice to see you. So, okay, I opened the chat on the phone so I can see it. So, figure out, first task, figure out why the texture doesn't render. And then I want to do what I set out to do on the last stream, which is, oh, this is weird. Okay, which is to abstract the textures. So for now on, that's what I'm going to do now. And I don't know later, depending on how much time it takes to figure out why texture doesn't work. I'll go on to abstracting the texture. And yeah, after that, I don't know. By the way, I just pushed all of the engine to zig down master. So you can actually go to zig down. Here it is. And if I refresh it, I should see the newest. There it is. Attempt to draw a texture quad, but no cigar. It doesn't work. So, you know, if you want to help, look into the code. You can check it out. It's in main right now. And this is where I create the texture. And this is where I load the texture, and that's basically it. And then I use the texture over here. So, okay. So what do I do? Okay, let's me first off show you where I'm at. This is my CPP engine. That's not important. This one is important. So building it, and there it is. So the texture should show white, right? It should not white, but show the texture. For some reason, it's completely black, and I don't know why. So let's let's try to see what's going on here. Okay, first off, I want to actually try to use a different texture because this one is not power of 2, and I'm wondering if that could be a problem. Like, okay, let's do some kind of a small texture. That is, yeah, can I find something? Tomb Raider textures. Oh, 256. Okay, there's a nice brick texture. Let's try to use this one. Save image as. This is PNG. Okay, let's save as a brick. And where is this? Is this in the? Oh, this is in the C. Okay, let's put it into zig down. So it's in res. There it is. Brick 256 by 256. Is it, just let me check. What does it say? What's the size? Wait, it should say like this. 256 to, okay, it is a power of 2. So in case that the power of 2 is a problem, let's check. So instead of res test, I'm gonna load res brick. And let's see. Yep, still black, so there is definitely a problem. Okay, let me try to not... Okay, look. Let's make sure that the shader is not the problem. I'm going to copy this shader. Let's duplicate it. Can I Alt D? No, Control D. No. How do you duplicate? Control. Yeah, there it is. Okay, let's name this texture only. Texture only. Okay, and in this one, I'm not gonna push a color. I'm going to push, and I'm not gonna push a normal, only UV. And the out is going to be the texture. So cutting everything out. The only thing that I need is this. Okay, so just making sure this is the minimal shader. And instead of my GLSL, where it is, yeah, frag, I'm gonna call texture only. Texture only. Let's see. Let's make sure that it's not the problem with the shader. And I need to not use this one. Looks like no. Looks like it's not a problem. Well, there's no problems either here. So yeah, there's something else is a problem. Something else is a problem. Okay, let's go through. Okay, let me fetch coffee first, and then I'm gonna go through all the stuff that I'm doing here. Okay, I'm back. Okay, so let's go through the OpenGL tutorial of making a texture. It explains that you need to have UVs. We do have UVs. These are texture coordinates. Oh, and here's our TV show, which we had on the previous stream. Real stream. Oh, real stream. Yes, this is a real stream. Hello, Blargum Jones. Holy shit, the ads are insane now. The real stream. Yeah, look at this. It's just it looks like clickbait, just pure clickbait footage, right? Okay. So anyway, the first thing that we do, okay, we have UVs, we push them. We set the GL parameters. So wait, it's not even allocating anything. No, that's it. Texture warp. So it's just doing everything. It's not even generating textures. Just setting the parameters. Okay. Border color. Border color. Is this even used? Border color. Mirrored repeat. If we choose the GL clamp to border, we should also specify a border. Okay, so this is just for a border color. Texture filtering. Okay, then it specifies min filter nearest. Min filter, mag filter. Okay, that's what I'm doing already, but I'm just using nearest for chunky pixels. And these are GL text parameter I. Yes. You know what? Let's glissert. But I can't do that. Engine glissert. Oh. No, it's not glissert. It's what's the name of it? But I didn't pub it. There it is. Log error. Okay. So let me log error in case there is an error. And I have to try. Howdy. I'm fine. Okay. Oh, look at that. There's a failure. Look at that. What does it say? Look at that. Found OpenGL invalid enum. Oh, we caught something. Okay. We caught something. Let's see. What's the wrong thing? GL texture 2D. Texture min filter, texture mag filter. Okay, let's use linear. Okay, so there must be somewhere there is an invalid enum. Okay, let's see. What's this? Texture parameter I. Okay, nearest. MIP maps. We don't really care about MIP maps. Texture min filter. GL texture min filter. Okay, that is set. But I don't have MIP maps. So maybe between the two MIP maps. Is this... No, this is MIP. This is between MIP maps. Okay. Loading and creating textures. STBI. Okay, generating a texture. Okay, unsigned int. Unsigned int. It's an unsigned int. GL gen textures. Okay, we gen texture 1. Why is there 1? Function takes as input how many textures we want to generate and stores them in an unsigned int array. Given as its second argument, in our case, just a single unsigned int, just like other object. Okay. So Yeah, this is just a pointer to the int, which is good. Now, okay, and we need to bind. Right, we bind texture. Gen textures bind texture. GL texture 2D, and we provide an ID, right, without a reference. Now that the texture is bound, we can start generating the texture using the previously loaded image data. Text is generating with GL text image. Okay, let's see. GL texture image 2D, GL texture 2D, 0, RGB. Oh, so I used RGB. They used RGB A2, A8. RGB. Could that be a problem? Is that the wrong enum? Let's see. Invalid enum. Okay, we have no idea where the invalid enum happens. Okay, let's do it like this. Okay, can I get a line number somehow? Source line number or something. Zig source line number. Compile time function to generate line number information. Is it possible? Find line information should be also part of metadata. This one is closed, so it must be return address. There's a better way to do this, which is with @return address. Put it in a function like this. This gives you a usize, which is the address of the machine code. It's called line info. Next, you can use stdebug to find out what source file, line column, compilation unit the address is in. This depends on having debug info available. This is the Zig way to do this, although line info would be convenient and work. Okay, so is there a built-in that says line? Line? No. Return address. This function returns the address of the next machine code instruction that will be executed when the current function returns. The implications of this are target specific and not consistent across all platforms. The function is only valid within function scope. If the function gets inlined, the return address will apply to the calling function. Okay. Error return trace. Yeah, I don't know. Let's see. Print source address. std debug. Okay, let's try this. std debug. Source. Oh, there it is. But it takes in an info. Okay, what do you do? std debug. Line info. Okay, so there is line info. How do you create line info? Debug line. Get line number. Address. Return address. Get self debug info. Find compile unit. Get line number info dwarf. This has been reopened. This is also closed. Source info. Oh, is there source info? No, there is no. Type info. Okay. In main. Capturing a stack trace and looking at debug info would not be very efficient. Okay, so what is the return address? Return address? What was wrong with a good old line? Yeah. I mean, there should be a way to do it, right? But yeah, the problem with line is that underscore underscore line is because it's a macro. Zig doesn't have macros, so it needs to do it in a different way. But yeah, apparently there is a way to do it. Inline call, okay. But the problem is that if you say inline address, it's going to point me here. Yeah, that's why it enforce inline from the caller, I guess. Inline call. Does it still exist? No, so this doesn't exist. I don't know if this is like a proposal or is this something that they removed in the meantime, because yeah, this is from 2019. So maybe, yeah, I don't know, maybe they removed it. But you know what? I can just log. Yeah, if I log, right, it's gonna show me exactly where it called from here. Yeah, well, yeah, I mean, I don't actually need an address because I can just throw these ones, right? I can just put them everywhere. And it's gonna tell me where the problem is. Okay, let's see. Let's see which one throws. Okay, so the one that throws is this one. Okay, it's the last one. Yeah, I guessed so. So maybe it's not RGBA or it's something else. Wait. So let me look at this code again. Let me look at this code. So first is a 0, whatever that is. Level. Okay, level I guess is just an array index. And then RGB instead of RGBA, and then with height. And then there's a 0 for some reason again. The 0 is border. Okay, so no border. And then there's RGBA. Oh, maybe it's this one. I need to make it into an RGB. Yeah, I remember somebody said a long time ago that you can easily mess these up. Let's try. Okay, and there's unsigned bytes. And then there's the buffer, which is the data. Okay, let's try. Okay, so it doesn't throw an error, but it's at least it's not an issue anymore. What about RGBA? Okay, it doesn't throw an error. What if I do RGB? Okay, so that works. So RGBA didn't work, but I still don't see the image. So I still have the problem, even though there are no GL errors anymore. Is it allowed to put two statements in one line? No, in Zig. Zig doesn't like that. The STBY loads function should return the channel count as one of the parameters. Yeah, that's true. It does return a channel, but you also have a thing which says desired channels. So I think that it will interleave the channels. So it will like allocate, right? Because it has like channels in file and it has desired channels. So channels in file means that it will yeah, so if the file has 3 channels and I give it 4 channels, I think it's gonna fill up RGB and put A into 0. Maybe that's actually the problem. Maybe that's the problem with my am I like multiplying an alpha or something? No, I doubt that's the problem. Okay, let's put 0 here, because I think 0 means use the same one. Don't like expect any channels. Yeah, well, that doesn't change anything. Yeah, because this one, you see, here they give an example of 0. RGB. Yeah, let's do RGB twice as we did. Okay. And we free the data. Yeah, we do that here. The whole process of generating a texture thus looks like this. Texture, gen textures, bind texture. Okay, let's check through the whole thing. So I allocate an undefined value. Generate the texture. Okay. Bind the texture. Okay, with the same one. I use as repeat. Okay. Wrap, filter, wrap. Okay, well, it's okay. Loads and generate. Okay, it loads it loads the data afterwards, but doesn't really matter. Okay, applying textures. So vertices, texture coordinates. Okay, I have my texture coordinates already. Enable attribute pointer. Yeah, I am already doing this. Now that we have to adjust the stride. Okay, let me check one more time how I transfer UVs from vertex. Right, I have in vec2 UVs, right, and then I output them through out. There it is, and that's basically it. And I output normals and I output UVs, and then in my frag I in and out UV, which is, you know, it's weird, but have you used RenderDoc before? Yeah, I could use a RenderDoc. That's true. But let's see one more time. Let's go through the whole thing and then I'll be desperate. Now we have to adjust the stride parameter. Okay. Forward the coordinates to the fragment shader. Okay, so yeah, we have text coordinate here. text coordinate becomes text coordinate, and then you take text coordinate and use that as the UV. And then, okay, maybe binding is the problem. Bind texture. Okay, let's see where I'm doing this. Main. Texture binding, texture binding. I usually start with RenderDoc, can see if the image upload was wrong or the vertex attributes were wrong. Pipeline stayed wrong, except. Yeah, let's see. So I'm actually binding twice. But texture vertex array, okay. Where is my vertex array bounding happening? It's actually happening here. Yeah, but I only have one texture anyway, so it doesn't matter. This is where drawing happens as well. So whatever I do in the render, I'm just going through each of the objects and rendering them. And rendering, so I'm binding a shader. Is it possible that I need to bind the texture here as well? Okay, let me try to render. Okay, let's bind the texture at the end. Let me try this actually first. RenderDoc is great for debugging, yeah. Okay, and let me bind the texture after everything. But yeah, I have only one texture, so yeah. Yeah, that's not it. Okay, well, I guess I'm gonna have to go with RenderDoc. Okay, let me also check. Yeah, let's finish this article. So, bind texture, bind vertex array, draw elements. Okay, I draw all the elements with triangles. And that's it. Frag color. Whatever. Yeah, it should show the texture, which doesn't in my case. GL active texture units. You probably wonder why the sampler to the variable is a uniform if we didn't even assign it some value with GL uniform. Using GL uniform, we can actually assign a location value. Okay, so they didn't actually even use the uniform. Let's not even use the uniform. Oh my god, it works. Okay, so I was going too much ahead of myself. There, I don't need a RenderDoc. So I guess nice. We have we have textures for the first time. Okay, so I guess that I was just setting a uniform for texture, which is wrong. I shouldn't put an ID. What should I put in that? The main purpose of texture units is to allow us to use more than one texture in our shaders. By assigning texture units to the samplers, we can bind multiple textures at once as long as we activate the corresponding texture unit. Just like GL bind texture, you can activate GL active texture passing in the texture unit we'd like to use. Okay. Active texture, GL texture 0. Activate the texture unit first before binding texture. You see, I completely forgot about this. I completely forgot about this stuff. After activating a texture unit, a subsequent GL bind texture call will bind that texture in the currently active texture unit. It's always by default activated, so we didn't have to activate any texture units in the previous example. So if you want to have two textures, basically what you need to do is you have to set int, yeah, you have to set as a different sampler. But it's not even, yeah, set it manually. Okay, but what is exactly the number? And we now load the PNG image. The number is a uniform, the number of a uniform. Or no, it's the number of GL uniform. 1i. That's the integer one, right? Okay, there it is. 1i. Yeah, that's the integer. OpenGL. Yeah. You have to tell OpenGL to which texture unit each shader sampler belongs to by setting each sampler using GL. Oh yeah, so basically you assign it to these samplers and then you assign it to an int, right? That makes sense. STBI set vertically on load. Yeah, I think I'm going to have to flip as well. Exercises. Yeah. So we got texture to render. That's good. But we have to make sure. Okay, let's add some texture abstraction so that we don't have to load every time. But I also want to make sure that test rendering multiple textures in a shader. Okay, so in my engine, I'm going to use a new struct. I'm going to create a new one. It's going to be a texture. So it's going to be a pub const texture equals struct. Do I already have a texture somewhere? No, I don't. Okay. So the texture is going to have, of course, the width. And yeah, we can just, it's all unsigned int, I think. No, it's actually a C int, which means it's I32. So by default, let's have it 0. Height is going to be 0. Channels 0. And the buffer. We have a buffer which is of type like the C pointer to any opaque, maybe. And it's initialized to 0, to null. I should probably not use it. Okay, I should probably use it as a like a buffer to U8. But yeah, let's add load function. And that's going to take a, well, I'm thinking C too much. That's going to take a path. Oh, I accidentally pressed Steam Manager. Okay. That's going to take a path, which is my const U8, right? A string. And that's going to be this. So instead of Yeah, let me actually keep these cints, but I'm gonna convert them with a self texture here. I'm gonna convert them into self width is, and now I'm gonna cast. Can I just do this? Or are they going to automatically cast? Probably not. Okay, return type. What is going on? Oh yes, it needs a return type. And maybe I should return. Should I return an error or not? I wonder. I'm gonna keep the buffer. Yeah, this is going to be oh yeah, of course it needs the C. So I'm gonna add the C import into the engine. Here we go. And now we can fetch the C STBI. And of course the path is gonna be this. Path is gonna be that. And we need to see here if, okay, I'm gonna have an error after all. That's gonna be a const error, whoops, sorry. Error, and I'm gonna call it invalid path. And yeah, let's try to do this. Well, yeah, I don't know if it's invalid path, but let's call it buffer. Buffer is null. Or texture loading, failed loading. So if buffer is null, I'm gonna return error failed loading. So then at the end, I'm just going to set all the things. Channels is channels. Self buffer is buffer. Okay, and then that's going to be my abstraction here. Oh, by the way, did I forget to commit this? Yes, I did. Okay, let me save the brick. I'm gonna say it works now. Texture only GLSL. Okay, yes. Texture now works. Texture now works with the exclamation mark. Okay. And yeah, here I have a load. I'm gonna have a bind function as well. Somewhere. Probably. Wait, let's see. Where is my... Yeah, there is the STBI. Oh, and of course, I need to free. I'm gonna do a D in it. That's gonna be a void. And if buffer is not null, then I'm gonna see STBI STBI free. No, wait, what's the one? STBI image free. STBI image free. And it's gonna be buffer. Okay. This one actually returns a... which one? Okay, well, this takes a question mark star any opaque, but this one returns the C style array of a pointer, an array, and this one actually takes a, okay, yeah. Anyway, let's see. We have, what else do we have here? So I've effectively made this into a texture. So let's use, oh yeah, let me make it usable on top. Const texture is engine texture. And then we have a texture here. That's gonna be texture, and we're gonna get a texture, empty one, and then we're gonna init it, not init, but load. Did I export? No, I haven't. Okay, make sure that it's pub, and we're gonna have a pub bind, and then we're gonna have, which one? Oh yeah, of course I need to have a self here. And this is not a buffer, this is a self buffer, and free the self buffer. And I actually need to make sure that this is, well, yeah, this is not actually going to be used ever. So we deallocate. What's the problem here? Maybe it just needs to be, maybe just ELS. Okay, so texture load, and at path of, what was that? Res brick PNG. Okay. And instead of this info, actually, let's just put a little log function here so that I can easily log textures, texture data, with height channels. Yeah, and I need a self here. And what else do I have? The buffer. Well, do I output a pointer? I guess so. Is valid. Let's say is valid. So I can say self buffer is not null. Does it actually output a true or and false? I hope so. I hope it does. Oh, I forgot my coffee. Okay. So yeah, after we load the texture, we also want to defer texture dinit. But let's log the texture. Okay, there it is. Instead of using this one, and we don't have to defer that. Okay, and now we want to create, like, you know, basically do open, submit it for the OpenGL like this. So I'm gonna cut this, and I'm gonna call here texture create. It's a weird name, but yeah, the reason why I'm putting this into two different functions is for is basically for multi-threading. So later when I add multi-threading, well, this is how I did in my C++ engine, by the way, because loading can be done in multiple threads. Like you can create buffers, but submitting for OpenGL needs to happen on the same thread. So this needs to be single-threaded, and this can be multi-threaded. Okay, so here we go. Try, okay, and we don't need to call engine here because it's directly there. Okay, and do we really need all of these? I don't know. Maybe I can reduce like the number of them like this by 2. Okay. Yeah. Gen textures, I create one, and also, oh yeah, I need to have an ID here. I completely forgot about the ID, which is I32, right? No, it's a U32. And by default it's going to be 0. I don't know if, yeah, I think that 0 means it doesn't exist. Okay, so instead of this, I'm going to do a self texture. Okay, and that's going to be mutable. I'm going to pass here self ID. So self ID. And yeah, I need to get a self width. Yeah, let's actually put a comma at the end so that it lists like this. It's a weird way of doing it, but I'm starting to like it actually. Self height, RGB, unsigned byte, and finally we provided a buffer pointer. Okay, so here we go. Okay, for now we're just gonna have this. Okay, let's put nearest just to have it a little pixelated. So there we go. We have effectively abstracted the stuff from main. So if I create, and finally we're gonna bind the texture, and I'm gonna use just texture bind here, and in bind I'll add this one, and that's basically it. And it's of course gonna be self, and oh, it's not self, it's texture. And this is gonna be a self dot ID. Okay, and of course I should check if, yeah, I'm not gonna check, just gonna fire in the dark. Okay, there we go. Binding, and I don't need to bind afterwards, I think. Texture bind, and of course this one is completely wrong. Shouldn't do that. So there we go. We have bound texture once, and I can actually bind it only once in my case, because I only have one texture anyway. Okay. Let's see. There are some bugs here, no? Okay, any opaque. C pointers cannot point to opaque types. C pointers cannot point to opaque types. What does that mean? What does that even mean? C pointer cannot point to opaque types. It's called any opaque. Should I cast it to a U8 pointer? So this one actually returns stbiuc. And I think stbiuc Wait a minute. It has created a temporary C import. Oh, nice. STBIUC. And that is actually a U8. So let's not do any opaque. Let's do a U8. Is that going to change anything? Aha, it does change. It says path is now incorrect because it needs to be a... is there a way to actually convert a const U8 to C const? What if I provided the 0 terminated? Yeah, okay, so that works. Null terminated is the same as C array. Okay. Not bad, not bad. Okay, so let's try to build now. Okay, error is ignored. Yeah, of course, I need to try. Error expected void found. What the hell? Because this can fail as well. Creating a texture. Okay, so I'm checking. Yeah, let's do... Or should I do catch nothing and just throw an error? Maybe I should do a catch nothing. Catch has white space on one side. That's it. Okay. There it is. And we have the textures. They're loading. We can look at them from near. Not bad, not bad. Okay. So there we have our texture abstraction. That's nice. Okay, let's test rendering multiple textures. But one more thing, I also want to test rendering multiple objects with different textures. Okay, so that's the next challenge. That's the next challenge. Okay, so what is the problem? The problem is that I don't have textures attached to shaders. Oh yeah, so this is a little bit of a problem. Let's add another texture. I'm gonna load the other one. Let's rename this to brick text. Okay, that's gonna be the brick text. Okay, then we're gonna have a test text is texture. Okay, we create one and try test text load. We're gonna load res test png and defer test text dinit. And then, oh yeah, we have these things, create and bind. Well, here's the thing, I'm not gonna bind, but I'm going to create this one. I'm not gonna log anymore, or maybe I should. Maybe I can log testx as well. And instead, here is a little bit of a weirdness that I'm gonna do. For each object that I render, I want to randomly. Okay, well, this is too magical. Scene render. Okay, let's go through each of the scene like this. Okay, just for a test. Okay, this is gonna be temporary thing. Okay, so for each engine scene objects const slice, I'm gonna try to render. Okay, let's see if this works, if this still works. Okay, it does work, but for some reason it's it's because this is a wrong texture. What the hell is going on? There's some kind of a okay, there's some kind of a mix-up of channels, I think. Beautiful. Beautiful. Okay, what's actually the text texture? It's not mix-up. I think it's just a shitty texture. That's the problem. Okay, let's find another texture. Let's find another example of a texture. Is there something that they provide us with? No. Okay, let's find another test. Do we have another example of a texture? Show off your cool textures. 512. Noise. Okay, let's do something. Okay, let's do this. It's like a boring concrete texture. No, actually, I want to use something nicer, something more colorful. Something more colorful. Tiny texture pack. Okay, let's do this. Oh, it's JPEG. I need a PNG. I don't have Photoshop here, I think. No, but I have Paint. Okay, let's paint something really quickly. Okay, can I modify precisely the size of this? Okay, I need to hit the right. Is there like, can I type in? No. Okay. So 128 128 by 128 one more pixel, please. Okay, there it is. Okay, so what do we draw? Let's do some. Is there, where the hell is the not the paint bucket? Oh my god, it doesn't have it. It doesn't have the old spray. I loved it when I was a kid. Oh my god, I can't believe it doesn't have it. What is this? This is some bullshit. This is not the paint I want. The spray can was the best thing ever. Okay, let's do this. We have a little bit of a blue, a little bit of a red, a little bit of a yellow. Make it a little colorful. I don't know, a little bit of a green. Like, it's fun. Well, something like this. PaintNet, the modern Paint 3D in Windows 10 is pretty decent. but I prefer GIMP. Spray can. Excalidraw. Yeah, I am actually using Excalidraw, but excruciating. Is a Photoshop clone in the browser. Photopea. Try with Half-Life texture in search. Wow, so many people suddenly are awake when I try to draw something. Something stupid. Let's add some purple because why not? Like a little sprite, little strip. Okay, let's do a little strip to cover the blue. There it is. And then I have like one blue stripe like this. I don't know, like this. Oh, it's perfect. It's perfect. Now I don't see yellow anymore. Oh! There we go. It's a perfect default PNG. Okay, so let's put it in zig down, res, and call it painting. Such a beautiful painting. Okay. There we go. Okay, so let's see. Here's the painting. Let's load the painting instead of the test. Painting. There's a spray in paint. Is there? But I couldn't find it. I just used Draw.io and Excalibur for everything. Ah, so I think the channels are completely messed up. It looks a little bit like Half-Life Lambda, actually. We can see that it's upside down. It's totally upside down. Is that even the thing I drew? It's not the thing I drew. Wait. I'm just confused. Okay, it is the thing I drew. It's just it's just upside down. So yes, I think I do need to add that line when I'm loading, when I'm initializing creation, which is like, where is the engine? Engine. Okay, so when I'm loading a texture, it's over here, and I'm creating when I'm loading a texture, I need to say C S to BI something like flip, set flip vertically on load. I think this is the one. Flag true if should flip true. But this is not going to convert into my proper. Is it? cint? Of course, it doesn't. So let's go with 1. Flip vertically on load. Okay. Draw.io. I never tried Draw.io. Draw.io. My god. What the hell is this? Save diagrams. Decide later. Unsighted. What? Untitled diagram. No, I don't want any diagrams. What is this? Did I use the correct leave? Oh my god, this is terrible. I don't like it. Okay, it's not Draw.io. PaintNet. Is PaintNet like actual website? No. PaintNet. Download. It's not for drawing, it's a program. Why is it called a paint.net then? It's very misleading. It's for painting. I meant Draw.io. Why is it so misleading? Okay, let me try this paintnet. Is there paintnet already? No, it's not. There's no. Get it now. Free download. Oh my god. So many. Okay. August 8th, 2023. Nice. Price paid. Okay, what the fuck is going on? Mirror host. So paintnet is actually paid. Whoa. It's 1,300 Serbian dinars. And there is actually a free version as well. Why is this website so bad? Yeah, because it has ads. That's how they earn money. What the hell is this? Paint, install any CPU web. Oh, I need the... Okay. It doesn't matter. Yeah, don't install that. What the fuck? I won't. No, mate, what the fuck? Stop, what are you doing? Yeah, that was some shit. PaintNet install any CPU web. Okay. Free open source, but with 1,000 ads. Okay. No, hold on. I wasn't reading the chat. Everybody's like, Jesus Christ, get an ad blocker. Use Inkscape. You're misleading, to be honest. You are misleading. It's for painting. Well, not everything. What I mean is when I'm trying to get an idea across or visualize. Oh, when you're trying to get an idea across. Yeah, I see. Oh, by the way, the zig down is rendering and it's correct. It's correct order, right? Is it? Is it already? Yeah, no. No, wait. It's still flipped. It's still upside down. Even though I said flip it. Yeah, wait, by the way, let me check. When I'm creating in my engine, there it is. Set flip vertically on load. I do actually use 1 on this one. So yeah, in my C++ engine, I do this. Yeah, so does this do anything? It didn't do anything. Crosshair visualize relationship, not draw. I can imagine GIMP being a bit heavy, but I don't think Plinta exists for Windows, so the equivalent to that would be PaintNet. Use Inkscape, use Krita. Jesus Christ, get an ad blocker. What is it you're trying to do? Is this even the right site? I just joined. No, hold on. Yeah, don't install that. What the fuck? Mate, what the fuck? Stop. What are you doing? That's the dodgiest looking file name I've ever seen. It literally open source. Whoever's charging money for that shit is an imposter. It's Foss here. Okay. Are the colors okay? Klecky.com. Okay, there's even Klecky. Just check your domains more carefully. It's not a speedrun. Okay. So, is this... wait, I keep forgetting. Yeah, this is the correct orientation. Okay, good. It does work. I just didn't rebuild, I guess. Cool. Okay, so that works. If that works, what's the next thing? The next thing is trying to render multiple objects with different... Okay, so what do I do? What do I want to do? I want to actually go through all the objects and then pick a random one. But I'm gonna like initialize my randomness. I have... oh yeah, by the way, I do have a PCG right? Somewhere. There it is. But let's make another one. Texture pick PCG. Let's call it like that. Rand PCG. Let's make another one. I'm gonna init to whatever. And yeah, actually I'm gonna init it every time before I draw a new one. So basically, this is what it's gonna be like. Why is it complaining? Probably because I'm not using it. And I'm gonna get a new. Yeah, let's try this. Let's try this funny thing. Texture pick PCG random dot boolean. Let's get a boolean, and I'm gonna say if boolean, right? So if true or false, it's gonna be random. I'm gonna then bind a different thing. I'm gonna bind a different texture. So I'm gonna go with like my text. What is my brick text bind, or else I'm gonna go with my other text, test text bind. Okay, so we're gonna, for each of the objects, right, we're gonna pick a random texture, and that's going to be consistent because the random is always going to be init to the same number before every for loop. So let's see what happens. Let's see if binding different textures work. There it is. It totally works, and they're all, you see, they keep their textures. This is a quick way of trying different textures for different objects. Cool. Everything works nicely. Nice. Okay, let's submit that. And this is, I've moved everything away, right? Texture abstraction, and rendering two different textures for two different textures for different objects. Okay, and I can push if you want to test it out yourself. Okay, so after this, let's go back. Let's not do this picking. Or maybe I should keep it for now. So what do I want to do now? I need to add another abstraction, because now, since we have different textures and we have different materials, we have different bindings for different textures. We need to provide different uniforms for every time we have different objects. Wow, this is just a weird thing to say, and I'm a terrible explainer. So basically, instead of doing this weird hacky thing where I'm just picking a random, I want to assign different textures to different objects. But how do I do that? Well, we are going to need to have uniforms per object somehow. And that we're going to use through a new abstraction, which we are going to call a material. So what is a material? A material, I was explaining yesterday, by the way. Where is my Excalibur? Here it is. So this is how the engine is sort of structured. Oh, by the way, this should be updated. So back in the day, in the first stream, I only made two things. I made a mesh and a shader. And I directly just bound the mesh and bound the shader. But now I have a scene. I've already have a scene. And I have the game object. So this is now going to be green because we made this. And so a game object contains, right now, has a mesh and has a shader. But in my C++ engine, the game object actually contains a material and not a shader. But material, what material is just a pointer to a shader and a list of properties. No dark mode. I don't judge. I just wonder why it's the inverse of your editor. Is there dark mode? Oh, there it is. I didn't know. Oh, cool. Nice. I didn't know that it exists. That's nice. This is where I was explaining. Oh, I was explaining alignment in my vertex. Cool. Okay. Nice. Thank you. I didn't know that. Right click in the background. Ah, Zen mode. Oh, cool. View mode. Stats for nerds. Oh, elements with height. Nice. Total storage. Cool. Okay. Anyway. So yeah, I have a scene. Game object, mesh, shader. And I want to add a material now. So yeah, by the way, I already have a transform as well, but I don't have it as position and why doesn't it resize? There it is. I do have a transform. I don't have bounds yet. That's something that is yet to be done. And now I want to add a material, an abstraction. Okay. And of course, I want to add a list of properties. To the material. So that I don't need to do this hacky thing. Okay, so we have a shader, right? And I'm going to add here in between the shader and the texture. Toggle grid is what I was hinting at. Show grid. Oh, not bad. Ah, you have a grid now. I see. Not bad. Whoops. I accidentally made a new tab. Okay, there it is. So the next thing, pub const material. Gonna be a struct. And what this is gonna have, it's gonna have a shader, which is a pointer to the shader. A shader. By default, I'm going to make it null. And it's going to have properties. And what are the properties going to be? Let's call them props. Should I call them with their full name? Props. I don't know. And a property is going to be... yeah, we're going to have a limited number of properties. So that I don't need to point it into some weird... so I'm just going to make it a bounded array. Bounded array. Well, at least for now. At least for now. And the type is going to be a property, but we need a new thing. We need a new property. Okay. And this is going to be a union of different things. Actually, it's going to be a tagged union. So we're going to do a union of enum, which in my case is going to be, yeah. So for the type of I32, yeah. So this is one of the cool things of Zig. You can have tagged unions which use types as their tag. And basically, so here I'm going to show you. I'm going to show you in my C++ code. I have a material which is material base. Yeah, I do actually like implement an interface, but here you have a struct which is property, and it has a type as an input, and then I need to test. I have a union which is data, and then you get a property, and you can set it one of the values. Well, here's the cool thing. Zig actually has built-in tagged unions. So for each of the type, I don't have to check is it an int, is it a float, is it a vector, is it a texture? Because it will actually save them, and you can switch on them in a switch, for example. And here you can see that for information, I have zero experience working with graphics, which I have been wanting to jump into recently, but Zig is why I'm here. Since I come from Rust and C++, and Zig is very intriguing. The graphics are a bonus. Oh yeah. By the way, I'm not explaining really well what I'm trying to do here, right? I'm trying to pack. I want to try to put different like values into a single. So because these uniforms that you push to a shader can be either an integer, it could be either a float, it could be either a vec4, it could be either a texture, right? And I want to put them into a single struct, which is going to be a property, and they're going to differ on the type, right? So the best thing to implement that is by using a union of different values. So what is a union? Well, a union is basically like it will hold the maximum amount of bytes for the value. So you could have, if I go to, so that you can have an array of things and it will hold different things. So for example, you have a grid of, bytes. These are by bytes. Beautiful. And then you could have for example, if your union has an int, has a float, and it has a byte, for example, which is like 8 bit, a single byte value basically. In Zig, of course, these would be I32, F32, and U8, for example. And in that case, when you put these values in an array, it's going to take the largest of these. So which one of these? Well, the size of this, oh yeah, by the way, the size of this one is 4. It's 4 bytes long, right? Because it's an I32 32-bit integer. This is 4 bytes as well, and this one is 1 byte. So the largest of them is either an int and a float. So it's actually going to occupy 4 bytes like this, right? It's going to take a 4 byte. So when you put it into an array, if you put it into an array, these are going to be individual members of this union, right? And the thing is that if you have put a value into an int, that's going to be an int, right? It's going to be like, okay, this is an int right here, and it occupies 4 bytes. If you put a float, it's going to be a float, right? And it's going to occupy 4 bytes with a float. If you put a byte, it's going to occupy 1 byte because it's only 1, and it's going to take this one. But of course, it's going to keep the 3 bytes empty because they all need to be aligned in a single, they need to be always of the same size. So that you could even replace this with a different value, right? But the point is that the union has fixed size and it can have different types in a single memory location. That's the point of a union. So to switch between these, you need to log which type it does contain currently, right? So in this case, I have a type which precedes my data, and I'm like keeping it in front. Basically, there's one byte, or well, it could be 1 byte, it could be an int. I'm not sure. There's 1 byte in between that tells which data it is. So, this could be a 0, this could be a 1, this could be a 1 for a float, this could be 2 for a byte, something like that. And the thing is that Zig has this thing built in. So you don't have to have the separate value of a type, int float vector texture. I can just create a value that is if it says union enum, then it's going to automatically have these types. But now I have to remember how you actually do them. How do you actually use them? Let's see. And they're called tagged unions. There it is. Tagged unions. Unions can be declared with an enum tag type. This turns the union into a tagged union, which makes it eligible to use with switch expression. Yeah, so you can see that it can be any tag, but in my case, I might have an enum of type. And let's see where it is, where there could be an enum. Is there an yeah, if you use it with an enum, then it turns it into a type, right? And you just assign which type it is. So in my case, I'm gonna say that this is an int, and it's going to be of type i32. This is going to be a type of a float. It's going to be f32. This is going to be texture, which is going to be type of, well, it's going to be texture type. Pointer of to a texture. And we're going to have one which is, what is this wedding thing? Which one? Oh yeah, we need to have vector types as well. Yeah, well, in this case, I do have to take all the... the problem is that the property could be also a matrix. So that's going to be a huge... That's going to add a lot to the union, unfortunately. But yeah, wait, let me see. What's the problem? Why is it... Aha, I don't assign it with a dot syntax. I made a mistake there. Okay, and vector 3 is going to be math vector 3. Let's do it with a vector 4 as well. Vec 4. Okay. And we have a vector 2 as well, if I remember correctly. And then we have a matrix, which is going to be a mat 4x4. So this actually makes it pretty big because it's going to be a 4x4 float. I'm just curious about Zig2. I write a decent bit of Rust right now. So by the way, talking of Rust, Rust has these things as well, like tagged unions, but they don't call them tagged unions, they call them enums. It's just like that you can assign anything to a value of an enum. So it's slightly different, but it's still the same thing. Okay. So I have properties, and these are going to be a bounded array of property, and let's make it 16 long. Oh, whoops. Yeah, we are not going to have more than 16 properties, right? If I do, I'll have to I'll have to extend it. But for now, okay, for now, I might use a separate allocator actually. What does it say? What's the problem here? Bounded array, buffer capacity, structure. What's the problem? Expected, found. What? I don't know. It should be correct. Init? No, that's not an init. It does take a buffer capacity of usize, and this is a correct usize. So what's the problem? I don't know. This is weird. After declaration. Okay, so this is the problem. Okay. So there we go. We have a material, and yeah, and so in this material, most of this stuff I assume is being Wait, 16 properties is enough for anyone. Bill Gates, I think. Most of this stuff is assumed being explained for the stream. The memory management is very interesting though. Also, Primogen mentioned something about an even better error handling system than Rust. Yeah, I guess the errors that he talks about is the error returns, but Rust has kind of a similar thing. I think the last time I tried Rust, it was a long time ago, but but it's kind of much more concise here, at least the syntax. You have the error return, which means that this can, you need to try things. If you return an error, right, then you have to try load this. And you basically, it's very similar to Rust. I think it uses like a question or something, which is like, well, is this gonna work or not, instead of try keyword. For allegedly, I'm here to find out. Yeah, it wasn't the distance concept from Rust. He called it the best implementation of it. Yeah, for example, I know that Rust has like optional, but in Zig basically you don't have the optional. Is like you make it like this. You put a question mark in front of something. You have var a question mark I32. So this could be it could be an I32 or not, right? And then if you want to use it, you need to use the question mark, and and then use it, like, assign a different value. I don't know. But then for errors as well, you have like this thing is an error. So this means that it could be an error or not. So you can make it a number, but what does it complain? Yeah, it complains because it needs an explicit error. So if you have an error, the error is just a type. It's just an enum. So you make it error enum, like this, and then you can say bad number. I don't know, something like this. And then you need to give it a, let's call this number error or something. So you need to give it a number error. There it is. And then what you can do is you can if you want to assign it to something else, you can try B, which will assign it to C, but with basically if it is an error, it will panic at runtime. But you can also catch. You can say B catch 0. So that means if it's not an error, if it is B, but if it is, then 0. So this is how you can avoid propagating error upwards. And the cool thing about this error thing is that this is a kind of a special type of an enum, which it's not coalescing. I don't know what it's basically combined with all the errors in the entire program. So if you have another error type, it becomes like a union of all the types, another error, right? And you have something else. But the thing is that these two errors will combine at while compiling. And the thing is that you could even have any error here. If you put an error keyword, that means it can return any kind of error. So this could be of type number error, bad number, but it could be also another error, something else. Something else. Whoops, something else. So yeah, it's like it doesn't have an error type which you assign, but you just put exclamation mark, and it will turn it into an error. And for optionals, it just have a question mark. So, but I know that in Rust you put like option like this or something. No, wait, optional I32 or something like that, right? Instead of just this. And also for pointers, you know, pointers can't be null. That's the cool thing. Pointers can't be null, so they kind of behave like references in C++. So if you grab a pointer to A, this becomes a pointer to A, right? But the thing is that if you do want to have nullable pointers, then you can simply make nullable pointer. You can simply make it question pointer I32, right? So this is like, okay, it could be, but it could be not. It can also be null. So instead of having references and pointers as two different things, it's you know, the optional pointer is the nullable pointer, but it can also be, you know, optional can be any type as well. Okay, anyway, let's see what the chat says. That was present in what he was referring. He praised the syntax. Yeah, I really love the syntax of Zig. You can do the same in Rust, but not so concisely. Quick question: does Zig have recursive enums? That's something I wish Rust had, which I miss from Haskell. Oh, that's interesting. It's like an implicit trait implementation over an enum. You need a Rust crate to do that, called anyhow, but Zig has it built into the language. That's awesome. Yeah. Anyway, I don't know what you're talking about. Does recursive enums? I don't know what recursive enums are. But yeah, anyway, that's a little reminder about optionals and errors. But I did this actually in my second stream or the third stream. Which one was that? In my third stream, I was going over a cool Zig features like captures, optionals, as you can see, pointers and errors, allocators and stuff like that. So yeah, if you go back into my third stream on YouTube, it is available. You can find out more about optionals and errors. But I did actually go over it now. Can errors have data attached? Last I heard, that was the difference. Yeah, they can't, because errors are just they're just you know, an I32 or a byte. It actually depends on the number of variants there is. Oh, and by the way, cool thing about Zig is that types don't need to be number. Doesn't need to be I32, right? It can also be an I31. Yes, that's right. Actually, it can be I30. It can be I3 if you want. It can be an I7. So it has like arbitrary width integers, and they will occupy the right amount of bits, right? U8 has 256 combinations, right? U7 has 128. U6 will have 64, of course. No. Yes, 64. And stuff. And so why is this important? Well, this is cool because, for example, there is one thing that's called packed structs, and if you create a struct that has, if you create a struct, well, this is weird. If you create a struct that has different, different numbers like I7, B I3, C U1, I don't know, something like that. which is also possible. So this is just a single bit. If you have one struct like this should be capital, then it's actually going to always align them to bytes, right? So this is going to be 1 byte, this is going to be 1 byte, this is going to be 1 byte, right? If you have a D which is like U15, it's going to be 2 bytes, right? Because it's going to align to U16. But if you make it packed, if you put a packed name in front, then it actually becomes bit aligned. So this is actually going to occupy 7 bits, and then it's going to be 3 bits, then it's going to be 1 bit, and that's going to be 15. And these are, and you can even, so this is a weird thing. You can even, okay, let's instantiate this. Stir is stir, and let's, oh yeah, well, let's just have, like, let's just initialize them so that I don't have to initialize them here. And the thing is that here's a funny thing, right? I can take a B and I can say, I can grab a B pointer, which is going to be this. And you might be thinking, how is this possible? If this is weirdly bit aligned, it's not really a byte offset. Well, that's because these pointers, zig pointers, can have additional. So yeah, a pointer to I3 can have additional info. So it actually stores a bit, which bit it is on, so that you can actually just do this and change it to some other number by dereferencing this pointer. So it has additional information. It's different than normal pointer, normal aligned pointer. So there's a difference between aligned and non-aligned pointers, right? And yeah, the cool thing about packed structs, even if I talked about in the first stream, if you, let's say that you have, everything is a bool, right? Everything is a bool. And bools, because in packed structs, bool now occupy bits. So when you change an I in a, if you have a stir and you say A is false, what this happens is that this false is actually a bit cast, like it's a bit operation. It's not, it's the same as, setting a flag in C++, right? And that's cool thing. That's cool because yeah, you get like flags for free basically, and you don't have to think about setting bits individually. But you just put you just pack it with bools, and you get everything for free, which is super nice. I mean, you get much less mental overhead. That's what I mean by setting them like this instead of like casting them to bits. Okay, so yeah, there is a simple overview of some cool Zig features. A new kind of smart pointer, you could say. Well, it doesn't have anything to do with smart pointers, but yeah, it's a pointer with additional information. Okay, you need a Rust grid to do so. Okay, can I skip that? Okay, well, in Haskell you can do data branch A, leaf branch A, and you have a tree. This is just an enum that can either be a leaf or another one of itself. I see. That's also really cool. A new kind of smart pointer, you could say. Okay, so let's go back to our textures. What was I actually doing? Oh yeah, I was creating a material abstraction, right? I have properties, and properties are different types. Okay. So let's see. Oh yeah, I need to also. Oh yeah, this is the data itself. property data. But I need to have a name as well. So this is not going to be... Okay, can you actually have anonymous unions in Zig? Like this. So I'm gonna call the name, and that's gonna be a string. Does this work? Tuple field has a name. Tuple field has a name. Tuple field has a name. What the hell? Okay, maybe this is not allowed. Maybe I need to put it like data. No, I don't know. How do I actually define this? Do I need to make it a name? Const data is this. And then I say data. But I need to put it over here. Could be like this. So yeah, that's actually like the payload of the property. Okay, so this works, looks like. But can it be anonymous or not? I don't think it's allowed. Okay, after. Let's see. Yeah, I don't think it allows it. Let's see. Can I... let's add a pub fn, let's see, self material. I'm gonna props. Let's append. This is gonna be called a add property. Append, and I'm gonna append a new property, which is going to be dot. Okay, let's see. If I add, okay, yeah, I should actually put that inside material. Doesn't work. Yeah, I don't think this is actually possible. Yes, you can do that in Zig, but as in Rust, it must be a recursive reference, a pointer, or just store an index and put the item in an array. In Zig, it's called union_im. That's the tagged union, what I'm doing. So I'm not sure that I can do what I'm trying. Yeah, let's put this into a data. Let me actually see if I can. Can there be anonymous unions? No, I think they need to have. Yeah, I think I need to access them. Okay, so I'm just gonna do that. So I'm gonna have data. Const data is union, and then it's gonna be this, and I'm gonna have data as data. There we go. And for some reason it still doesn't work. Struct. Okay, wait. So something is failing here. Does this work? Nope. Okay, yes. Oh, property. Okay, why does it not? Okay, well, return type missing. So how do I define the data now? Data is, do I do it like this? Dot int. Let's do something like this. And dot name is property, just for a test. Okay, there it is. It actually works. Append item, and this needs to be a try append, of course. But yeah, let me propagate the error. Wait. This could be inferred. And here I'm gonna add a, okay, there it is. And if I remove this one, cool, not bad. There it is. I think this should work. Const tree union node struct value left 3 right 3 leave void. Just tested it on Godbolt, it works. Text learn x cine in the background. I was hoping you wouldn't have to do that. Okay, there's another discussion happening in the chat. Okay, so yeah, let's not add this as a self. I'm gonna add it as a, so here I'm gonna add, you know what, we're gonna add these properties maybe in the, yeah, this is just a little test. I'm gonna add these in main actually. So yeah, the texture pointer. So okay. Let's see. So how do we bind this, right? Because we need to bind it as well. Bind, and I'm gonna say that for each property, right, I also need the self here. Self material. For each property, I don't need a, okay. Self props, prop, and for each of them, I'm gonna switch on the prop data. Okay. And now I need to handle each of these cases. So I'm gonna say, oh, you know what? Actually, I might not need to do this. Can I just grab the data as it is? I wonder. I wonder if I can pass the data into an anytype without having to switch on it. Like, yeah, I wonder if I can unwrap it and just send it to the shader. So I just say shader, self shader. I need to, of course, test if self shader. I'm gonna say if self shader shader. So I capture the shader from an optional. And then I do a for each. And for each of these, self, oh yeah, shader, set uniform. And is this actually static? It is. I call it static, but I mean it's not a member. So you need to call it like this, shader. And the location, no, I need to set uniform by name. Set uniform by name. I'm gonna make this a prop name, and the value is gonna be prop data. I wonder if this can work, but I doubt it works. Okay, and then the shader itself is going to have shader bind. Yeah, I'm just gonna bind the shader and then assign the uniforms. Let me actually click it, get the test to toy around with this, since Godbolt doesn't have a full compiler. Lying on the linter to see if something is a valid syntax, but I want to run it. Okay, let me actually make a quick test myself of like, let's do a quick test of like, does this work? In union tagged union anytype, can it coerce to an anytype? I wonder. If we go and yeah, I want to just copy Zigdown's VS Code. So yeah, what I was trying to say is that if you have an anytype, if you have a function fn takes anytype, and I pass in data as anytype, if data and I say if type of data is I32, then like log info, it's an int, something like that. Else log info, it's not an int. So let's just test if takes any type, and I'm gonna make it a 34. That's the comp time int, so it's not gonna work. Okay, it's not an int. Okay, but if I say as I32, right? Now that's going to coerce to an I32, and it should say it's an int. Yeah, it's an int. Okay, but what if I have a union? My union, which is a tagged union, and it has an int. Dot int is I32. Oh, it's type of I32, and I have a float, which is a F32. Okay, and then I instantiate. Oh, right, and I don't need dots. I keep forgetting. Okay, and then I have instance of my union where the data of int is 34 again, and let's check if takes any type 34. Sorry, my union. What's the output? What's happening? Aha, it's not an int. Yeah, so it's not an int because the type of it is probably log info. Type union type. Type of my union. What does it say? Yeah, it's main my union. B void ca height compass. Okay, I don't know what you're talking about. Something else completely. But yeah, how can I actually get the data? Is there like a union in it? What the hell is a union in it? Active field name, init expression. Is there a way to get, maybe there's like std, the fact that the definition of a contain itself. What if I get meta union field enum returns an enum with a variant named after each field of t. Okay. Tag name. What's a tag name? Converts an enum value of union or union value to a string literal representing the name. Okay, interesting. So if I pass it the tagged union, let's see what it says. Aha, it doesn't work like that. Compiler cannot form slice without a specifier. Okay, that needs to be a string. Aha, it basically unpacks. It sees which one is active. So maybe this is a way to get it. Tag. Okay, but is there a way not to get the name, but the actual union thing? Instead of using a switch expression. What is a anonymous can be used to initialize unit without specifying the type? Aha, emitting the struct type. As the meta active tag is another one. Ah. Hello, you want to know which tag is active? Yeah, basically what I want to do is I want to pass the active, basically I want to pass the union into an any type. So that it takes the correct, data. That's what I'm trying to do. Like an any type function, I mean. So that I don't need to switch and then go like, well, use this call this one on the same thing. May I ask why you want to do this? Well, because I already have a function that takes an any type, and then depending on the type, it will call different functions. And then I just want to use a new thing. Where is it? Engine. Yeah, like in the shader. Shader. There it is. I'm calling different functions, OpenGL functions, depending on the type that I pass it. And then I want to do the same thing, but now I have a union of all these types. So I want to give it a union, sort of. And then it should take the value and switch on in this way. But this one takes any type, and then at compile time, I get, you know, depending on which one it is, it calls the correct one. Let me try with. So yeah, what did you say? There is a meta active tag. There's even a tag payload. Given a tagged union type, return the type of the union field corresponding to the enum tag. Return the type, the type of the union field. I don't want the type, I want the actual payload. Returns the active type tag of a tagged union. This one also returns a type. No. It returns a tag. It returns okay, so then the tag, does it contain a... Okay. Let's see. My union dot data. No. Can I do this? No. But this returns a tag. So I guess you can use tag. No, you can't. std meta tag. What is it? Okay, I don't know. I think it's just confused. All these inline aren't necessary. Switch x int payload. Yeah, but I'm trying to avoid having to switch through each of them. That's the problem. I just want to give it the active tag. Okay, let's try active tag. Didn't I try that just a moment ago? active tag of my union. But it doesn't give me any intelligence of what the tag has. Okay, let's see. Why doesn't it return? Okay, let's see. Maybe ZLS is not working. Okay, so this is actually a type. Maybe I can help if you start writing the actual code instead of this probe code. What do you mean? So basically what I'm trying to do here, okay. Wait, does it have a capture? I'm still trying to know what you want to do. Okay. So, okay, I'll do just a normal switch on a union. How does that work? Now I have to remember. Switch C, that's complex type, right? Yes, switch and C. Okay, and then you get. Okay, you don't capture, but you do my union dot int. But I think you can do just this. And then, okay, you capture the value like this. Value, and then I pass this value to take any type. Like this. So, here's the thing. Now I have to do this for every type, right? If I have many types. And what I want to do is exactly the same, right? I just want to grab the type and then pass it to this function that takes any type. That's the thing. That's what I want. So I want to just grab the active data and pass it to any type. But I don't want to switch through each of the values. That's what I'm trying to do. You understand now? So if I have like anything else, yeah, let's try to do this. Let's try if it's an int. Yeah, so this works. Switch inline else payload my func. Oh, does that work? I see now. Okay, that's that. Would that work? Payload. You call it payload. Okay. Takes any type. Payload. Let's try. Whoops. Where is it? It's not an int. Okay, well, this is weird because it should be an int. It is an int. And the anytype should give me an int. What is going on? Why is it wrong? It's not an int. Inline else. Oh, that's the problem. Okay, so now it works. Okay. Okay, now I don't understand why. So this means that for each type, it's going to create a new else. Yeah, this is weird. This is weird. Yeah, like if I was reading somebody else's code. So, okay, this is the first time in Zig that I feel like if I was reading somebody else's code and I encountered this, I would be like, what the fuck is going on here? Yes, it's not inline else makes a switch case for each at compile time. Yeah. I would stop and freeze and be like, it would be so much nicer if it was possible to like, do active payload, and just pass it to takes any type instead of doing this. Well, maybe not like this, but with either with that active payload. Something like that. Okay, so cool. It works. It's kind of similar to inline 4. Yeah, that's true. I've used inline 4 before. But yeah, why do you think that in this case, you said that this doesn't need to have inlines? But basically what I'm trying to do is I need to check I need to make sure that the set uniform is gonna like only instantiate one of these and not all of them for each of the types. Basically, I want the switch to disappear, right? When I instantiate this function. And if you need the tag at comp time, inline else tag, right? But yeah, let's do material. So, set uniform by name. I can't do this, but I can switch on a prop dot data, and then inline else data, and then we have this. Is that the same one? Oh, it's actually not. It's it's not a colon. It's a arrow. All right. Oh, and I take the data instead of prop data. Okay. So you don't need the inlines for that. Yeah, the switch disappears already because you're switching on a type. Oh, I see. Set uniform. Okay, so the switch disappears already. I see. So I can just remove this inlines completely. And by the way, do I actually need this compile time check before I use it, or I could just have a compile time over here, because now right now I have to double this. I have to check if type is if type is each of them, and then for each of them I have to add a new one. Yeah, comp time is unnecessary there too, I believe. Okay, let's try to build first and see what happens if everything still builds. There it is. We have those random textures still. Okay, let me try to add this comp time over here. And then type name, type of value. Okay, let's add this here. I'm gonna remove the comp time. Let's see if this works. And then switch on T. Okay, that still works, but what if I pass it the wrong type? What if I say try shader set uniform? I do something, and then I say engine. You know, I just pass the engine type. And now it should fail. Uniform with type of engine is not supported. Perfect. Okay, so yeah, I completely didn't need this type checking in front. That's exactly what, there it is. It calls this compile time. Cool, cool, nice. All right. So what do I do now? Since we have materials, we don't need the objects now should not contain shaders, but they should contain materials instead. So we need to remove the shader and replace it with a material. This is going to be now a material that we're gonna, yeah, this is gonna become a material pointer self material, and then we bind the material, and for each of the ones that we render, we are going to material. Oh yeah, binding already works with this set uniform name. All right, we are actually going to bind M. So material pointer shader. Wait, what is going on here? Shader. Material should contain a shader as well, right? It is somewhere. It does contain a shader, yes. Okay. But it is an optional. Set uniform name. Okay, we are going to just blindly do it like this. Ziggy is often kind of hard to tell what is comp time versus runtime. Yeah. I find that hard as well, but it seems to do a pretty good job of figuring out what is comp time known somehow. Yeah. Okay, so this changes. Material is now different. And so we're still rendering everything. Add object. Oh yeah, well now we're not actually passing a shader around. we're going to pass a material, a pointer to the material. This is going to be a material. This is going to be material. That's pretty much it. Okay, and then when we're creating a shader, of course, we shouldn't have shaders that we pass to the object. Let's see. Shader compile. When we create, oh yeah, there it is. So I'm passing a shader here, but instead I should actually have materials, which I'm going to create here. So I'm going to make two materials with two different textures. Material. Okay, let's go with test material. Now material should be a thing here. Okay. And the shader is going to be shader. And properties are going to be oh yeah, right. This is actually going to be, this is my array. No, how is it called? Bounded array. So maybe the bounded array should be initialized to default. Yeah. Go to definition. Bounded array. Let's just initialize it to nothing. Okay, so that we can just provide a shader. And then for test material, we're gonna take props and we're gonna append a new one. And for, yeah, it's gonna be what? It's gonna be name is gonna be texture, and the texture is gonna be, oh yeah, where am I actually loading textures? I'm loading them here. That's it, right? The texture is gonna be brick. No, it's gonna be test text. Okay. And, well, what is going on here? Append. Yeah, this all works. This all works fine. But this is the problem. Shader found engine shader. Aha, I need a pointer to the shader. Yeah, okay. Well, let's put that in line like this. Okay, and I'm gonna make a brick texture, brick shader as well. Brick material. Gonna take the same shader, and we're gonna have the same prop, and this one is gonna use a brick text instead. Okay. Yeah, let's have this so that it's in line. Okay. Oh no, it's actually dot data dot texture, or dot data equals. Yeah, this is a bit annoying. Data equals the texture, and of course this should be a pointer. But there is a problem. There's a problem with the texture. Because when I'm binding, oh, this should be a brick texture as well. Brick material, sorry. Brick material. Okay, you know what? Let's not do textures at first. Let's do colors. Let's do colors. Because textures might be a problem. Let's put it a properties append dot name is color, because I already have color, and data is gonna be dot vec3, and the vec3 is gonna be color. Let's do red and to vector. Okay. And then I'm going to do the same thing for the brick material instead of appending a texture. Brick material. Color, data, and it's not going to be red, but let's do it blue. Okay, there we go. What does it say? Expected type found vector 4. Oh, it's not 2vec. It's... Is it vector 4 or is it... Let's see. Where's my frag? Where's my frag? There it is. Color is vector 4. So let's actually convert it to vector 4. Okay, and that's not going to be a vec3, it's going to be vec4. Is that going to work? Yes, it does work. Cool. But append doesn't work. Consider trying. Try. Oh yeah. Okay. I need to do this. What up? And creating materials, adding material abstraction with properties to my engine. Okay, so I have these two materials, and now my objects should take either one or the other material. And here's the thing. I have... okay, I'm gonna create random sphere mesh. Right, let's have... Which one is which? What does the sphere go? Sphere go, sphere go. Go to definition. Doesn't really work. Ah, it is the definition. Ah, this is just two of them at the beginning. No, yeah, we're gonna give it test material and brick material or something. But at the beginning, I'm actually going to add... Yeah, I'm gonna basically add random. So let's do... Oh, there is a PCG. Let's do that. Let's use the PCG. So if PCG random bool, then I'm gonna either add this, right, or else I'm gonna do another thing which is almost the same, but instead of test I'm gonna use a brick material. So it's gonna like mix up different materials. And then instead of doing this, let's hide this for now. and get the scene back. Oops. Let's see if colors work. Oh, by the way, I'm not even setting color. I'm not even setting colors, right? Because I'm using this test material, test shader. Let's see what happens. Yeah, instead of texture only, let's go back to frag. Oh, following command failed. Bounded array is not indexable and not a range. Okay, so it's not props. It's actually const slice. Okay. Expected 3 arguments. Found 2. Ah, okay, it takes a self, so it's a shader. But I think set uniform can fail. Yeah, so I need to call try. Oh, but then it's not gonna work. Okay, let's propagate this. Just in case. Prop name. What's the problem here? Set uniform. Const unit. Ah, it doesn't have a sentinel. Prop name. Okay, let's make this prop name. Let's make it use a null ending thing. Slice. Okay. And then when I'm binding a material, I need to propagate the error as well. There it is. Okay, try bind. Okay, another error. Uniform with type of engine texture is not supported. Yes, this is a problem because we don't have a texture yet. But wait, where am I actually trying to do this? It doesn't give me any other path. Because I'm not yet trying to do this. Amn't I? What is the problem here? Set uniform. Maybe it's this, or is it? No, it's not that. I'm not trying to set any, well, this data is factor 4. I don't know. No clue what you're doing. I'm gonna sound stupid, but how you actually test this without visual? Well, Zig helps me because it throws errors and it says everything doesn't work. Okay, so for some reason I'm appending a texture which doesn't work. Somewhere. I don't know why. Why it doesn't give me where I'm actually calling it from. Reference by. Oh, there it is. Reference by set uniform. Anything else? Do I have, is there more bind? Okay. Ah, this is a compile error. Ah, I think it's just trying to instantiate all of them. It's could that be possible? That it's trying to instantiate all of them at compile time, and then it throws even if I'm not using it. Interesting. Let's try to just remove it from existence. There it is, it works. And there, we have different colors. Red and blue. Nice. Sometimes doing zig build f reference trace helps. Okay, let's see. Zig build. What is it? Reference trace. Let's see. Let's fail it again. All right. We do have... Oh yeah, we have a whole thing. Bind render main. Okay. Called from there. Try object render. Okay. Material binds. Yeah, it is actually... Well, I'm not using texture at all. But it's definitely else. Inline else is trying to instantiate all variants, all possible variants. And that's the problem. Yeah, it works without the texture. Okay, so let's not have textures for now. But that's great. It's great that test material and brick material works. Like, I mean the red and the blue. So, cool. Okay, let me add this thing. And I'm gonna say material abstraction. That's a pretty big refactor of the whole thing. I changed so many things. And this thing I also cleaned up. Materials and properties. Okay. Another thing you can do is that switch texture is unreachable. That's true. That's true. Like this instead of commenting, so it doesn't try, so it doesn't attempt to call this, which is not supported. Okay, yeah, that makes sense. Cool, thanks a lot. Okay, so my next task is to implement textures. Binding different textures. But yeah, I have to remember how I'm actually doing it in game. I think I need to count which textures I'm using, because textures are not trivial to put in as a set texture. Property date the texture. Yeah, when I'm actually going through each of them. Where's the switch? There it is. Okay, so this is what I'm doing. I'm binding. Oh, interesting. I'm binding a texture unit. I'm simply simply counting the textures. That's actually slightly incorrect. Because if the order is incorrect, then it won't work. But it actually worked so far. So surprisingly, it works. Okay, so when I'm actually binding, a material, I calculate which one. Oh, I'm doing this wrong. Let's call it the same thing, texture units. And then if it's a texture, I'm going to texture, I'm gonna like, let's grab the texture. And then what I'm gonna do is that I'm gonna set uniform, and that's going to be a location is going to be the name. Set uniform by name. Prop name. But the value is actually going to be the texture unit. And then I'm gonna add 1 to the texture unit. So am I actually using the texture or not? Oh yeah. I need to bind the texture as well. It's a pointer, so I don't need to unpack it. What does it say? Oh yeah, it's wait. Error is ignored. Consider trying. Yeah, that should work actually. So now we can also append a texture. So let's just append props append texture. This is a test text. Okay, and then for this one, we're gonna append the brick texture. Oh, something else might help the workflow. Add this to your tasks JSON, and it should give you squigglers for build errors. Problem matcher. Oh. Where should I add that? But I mean, I already have squigglers, no? problem matcher. What's the dollar sign for? Dollar sign zig to one of the tasks. Okay, let's see. What does it say? Oh yeah, this needs to be a pointer. And it doesn't work. Okay, so let's try something. Let's try. Oh yeah, what if I do this? What's the point of the problem matcher? Is it going to give me... Well, I already have the squigglies, so I think it's on by default. Okay. I don't know what the dollar sign means. It's just what VS Code auto-completed. Texture bind texture unit. Okay. So yeah, if you have multiple textures. Oh yeah, and I'm binding the texture here. So that means that I should remove all the texture bindings I already have. Where is my texture binding? Brick text. I'm not binding any textures. Test text. I'm not. Okay, that's good. That's good because this should bind the texture automatically. But I need to initialize the texture unit thing. I do only have one texture unit though, so it might not do anything. Where is it? Yeah, texture binds. Right. It actually takes. Texture bind. Okay, I'm gonna provide this with a unit. Texture unit. And then I'm gonna have, yeah, let me add glog error. Catch nothing. Just in case. Okay, so GL active texture and GL texture 0. Oh, it's not 0. Cool. Texture 0 is not 0. And then, oh, slot. It's called slot. Okay. Okay, let's activate the slot. So then, when I'm binding a texture, well, yeah, let me go to the next error. where is my texture bind? I need to provide it with member function expecting one argument. Yes. I'm gonna provide it with the texture unit. Okay, let's try this. That should enable more squigglets beyond simple int errors. I don't know, I don't use VS Code much anymore for Zig. Expected type CUint found I32. All right, yes. Let's int cast. Is it going to automatically cast it? No. Okay. What is now? It's same error. Expected type CUint found I32. Oh, this one is GL enum. No, that's not the problem. Okay, then I'm gonna convert the opposite. I'm gonna convert slot into cint. Is this going to work? Expected type CUint found cint. Ah! This takes the CUint. That's the GL enum. There we go. Okay. Do they use different textures? I can't even see. No, these are all brick textures. Cool. So it doesn't work. Okay, let's thread through what is going on. I have two textures, right? Brick texture, brick, and painting. Everything is brick, everything is test. Create the test material. When you say material, I create a brick. The append color test text. This one uses a brick text. Let's simplify this by not adding manually props. No, let's do props. Add property. I actually have a function. Let's call it add prop. Self material. It's gonna be name. Name is gonna be null terminated slice. Const u8. And the property. Okay. We have now the opposite problem. What if I pass it in any type? Right? And I want to map it into, I want to put it into a union. So basically what I want to do is self props append name is name and data is, and then you have like value. But I need to infer what the tag name is. Union init. Ah, I see. Wait, what? I see it. That should enable more square. I see it. Line 74. Good old copy-paste error. Where? 74. 74. Texture. Brick text. Ah! There it is. Okay, yes. You told me that init, union init. Union init. Nice. Comp time. Type. What? Okay. What is this about? What is this init expression thing? So I give it a union type, which is my data. Oh, it's actually property data. Active field name. Well, what is this? Init expression. Okay, I don't know. Let's look into union init. This is the same thing as union initialization, except that the field name is a comp time known value rather than an identifier token. Okay, so I guess I need to switch on the type now. Unfortunately. Okay, let me get as type of t whoops, type of value, switch on t. So if the type is I32, I should union init. No. Well, actually I can pass it. I don't need to init, right? You can use tag name tag. Wait, but you have to pass a comp time tag for the tag name. You'll need to pass in a comp time stud meta tag texture. Ah, along with a value. So it is possible to not switch. Union init let's see, active field name. You mean this one? Tag name. And something like this. Compile error. Deprecated. Use tag name or error name. Tag name tag. Need to pass in it. But why would I add a parameter comp time tag into my add prop? I don't want to do that. Okay, so what does tag name do? Converts an enum value or union value to a string literal representing the name. I see. So if I do this and then in union init I pass property data, and then for the tag name I do this, is that possible? And then expression is value. Is this possible? But what does it return? It returns a union. Okay. Is this what I'm thinking about? Okay, so let's append. Props append. Oh, I don't know why I actually deleted the name thing, because that's it. Just the data needs to be this. I wonder if this is going to work. Yeah, well, I'm not using add prop, so I'm not using anything anymore anyway. Okay, so now instead of this thing, I can do a try. Let's try with the color here. Instead of this long way to name it, I'm gonna say try test material props. No, test material add prop, and then I just have color, and value is color, which is gonna be color red to vec4. Like this. Yeah, it makes it like almost twice shorter to write this way. So let's see. Please build. Please build. Oh. Okay. Expected enum or union found math vec4. So this is incorrect. Can't do a tag name. Oh, I think I misunderstood. I don't know what value is anymore. Value is an any type. Basically, I just want to cast this one into a corresponding correct, right, type. Here. That's what I'm trying to do. So I want to create a union. I want to append a union that will have a correct, that the value of this, it can be either at I32, F32, whatever. It could be a pointer to a texture. And then I want to assign this data to the correct value. Yeah, that's basically it. So what exactly is this init expression? This is what I'm confused about. What the fuck is forwards its result? This is the same as union. Initialize except that the field name is a complex number. Then okay. And the expression would be int float for texture. The payload. Okay. It's the weird it's a weird thing in its expression. Instead of calling just the value. And then what is this active field name? Okay, I need to get the field name of the correct tag, basically. But tag name is not this, isn't it? It should be like a field name. Yeah. Tag union. Is there this std meta tag payload active tag? So how do I get the name of the tag, but for a corresponding union? Like, I'm surprised that it doesn't actually ask for like the union itself. That's what I'm confused about. Because what does tag name of value actually mean? It means nothing. or union value to a string literal representing the name. I guess a switch on the type is fine when as long as they all have distinct types. I mean, this will just simplify adding new types. That's why I like. That's why I want to avoid it, because if at some point I'm gonna be like, oh, maybe I want to add color. So if I have color, then I have to add a new thing. Can't you infer active field name from type of value, any type? Yeah, but how do I assign a value to a union? Like without knowing, because you need to give it one of the values. If I give it a yeah, active field name. I'm confused about this active field name. What the hell is an active field name? Can you just initialize a union by giving it a value? I'm really confused. Type of to get the type. And set the union names to add whatever type of returns for that type, then put it into union init. You try writing the code you want. Well, here, right? I need to do this. Basically, okay. What do I want? Can I get? Okay, this is what I'm trying to do, right? Can I get this name, this int string, by getting from a type? Can I say, give me a name of tag, and then I pass it data and I say I32, right? And then I get a string which is int, right? This is the result. That's what I want. But instead, this tag name thing actually takes only one value instead of getting instead of passing a union as well, which is strange. No, there's no built-in way to do that in the standard lib I know of. Yeah, so what I'm trying to avoid is doing a switch again, right? Because I would need to do like property data. Data is switch, and then I would have to do like t, and for each of the types if it is I32, I would need to set data as, oh yeah, I need to just return int is value, right? Like that. And then I have to do that for every type. Right? For f32, I'm gonna have to make it a float. And I'm just trying to avoid this, doing this. I mean, it's a small thing now, but in the future I might. So basically, yeah, basically what I'm trying to do is inverse what I was doing previously. Inline 4 fields. Oh, can you do that? No, there's no, you have to either switch on the type. Inline 4 over the tags of data. Okay, what about that? Like this. Okay, let's try to do this instead of all this. And then I try if field. What can I get from the field name? I think that ZLS is broken here. Name type value. Okay. So if field type, will it work for field type? Is T. Field name. Okay, then I do union init with the property data, and the field is going to be field name. And init expression is going to be value. Okay, well, it would be funny if this worked. Okay, yes, so and there should be can a for have an else? Okay, then I init with the value, and then return is, I'm gonna have prop Oh yeah, let's remove this. Actually, I can directly do a return. No, I can't do a return. Wait, I'm adding a property. So this is gonna be a variable, or is it going to be a const? Okay, let's do it like this. Const, and then I'm gonna say dot data is this. Great. Expected equals, of course. Okay, except that I'm gonna do this. Okay, hopefully. And then what I'm gonna do is self props append prop. But I can do that actually in line here. Okay, and then if nothing of that happens, I append and I return, basically. And if not, I don't actually need a type. Oh yeah, I do have a type. If nothing, then I can do a compile time error, if that works at this point. Unsupported property type. Let's see if this works. Yes, for can have an else. This syntax looks like SHA-1, but actually I don't, I'm not how would I say? I'm not disliking it too much. Consider using try. Right. I need to try because it can fail. Okay. So yeah, let's see if this works. Add prop. So basically, this should infer the type. Okay. Hello, it actually works, and we have correct sorting, correct textures as well. Nice. Okay. So we can now change our syntax to a much simpler one. So try test material add prop, and it's going to be texture, and the value is going to be simply add test text. Nice. Yeah, literally half. Okay, and then we can do the same thing here, except that I'm gonna pass a blue, and I'm gonna have a brick text here. Let's see. Oh, it doesn't work. It's all the same texture and the same color because I copy paste. That's why, of course. Of course, as you do. I agree Z can be verbose. Oh wait. Yeah, there it is. It totally works. Nice. Nice. Okay. So, what if you add a type which is not which is a bad type, you know, bad prop, and I'm gonna do like I'm gonna pass in something that's completely crazy, like engine again. What's it gonna say? What's it gonna say? Bang! Compile error. Unsupported property type. There we go. Very nice. Let's make it nicer. Type name T is an unsupported property type. Haha, engine is an unsupported property type. Okay, there we go. Now we can erase everything and oh, much nicer syntax. Let me just add a little comment here because I'm definitely gonna forget. Finds property. Wait. What? I don't know. I don't even know how to explain this. Sets union field with the correct type. With the type deduced from type. With sets union field deduced from type value. Something like that. Okay, cool. Let's add that. What does it say? Okay, textures and textures are now added as properties. Textures as material properties. Textures as material properties. That's basically it. That's the major difference. Okay, so cool. We have materials. What do we do with the materials now? Okay, one more thing that I wanted to do is to make sure that you can actually have like two different test rendering multiple objects with different textures. Done. Test rendering multiple textures in a shader. Okay, so what if one shader has two different textures? So we need to test the thing that's called texture units. Yeah, that I actually already have. I just don't have. I don't have the. Okay, I can shut this down. I just don't have the shader that accepts two textures. So let's just try. Let's make a duplicate of this and call it two textures. Two textures. Okay. I'm going to add another texture. It's going to be called texture 2. And this one is going to have a frag. Yeah, we're going to have two textures here. Text 1 and text 2. Right, and it's going to be vec4. Texture 2. And what we're going to do is we're going to blend between the two. Yeah, GLSL doesn't have lerp, it has mix. So it take 1, take 2, and then let's mix them in between. Something like this. By the way, there's some more messages from people. Okay. I agree okay. I agree it can be verbose sometimes, but it's almost always more readable for me than C++ or Rust. Yeah, definitely. I absolutely agree. Like, you know, even I was just thinking now, like, should I really write this? Because it kind of makes sense, right? If I go through, I'm like fields, okay, I'm getting fields, I'm appending, and I'm like inferring the data out of, like, it's actually makes sense. And I mean, the most amazing thing to me about Zig is that you can go to anything. You can go to anything in the standard library, and you just understand. You just understand what the stuff is. Like resize, okay, obviously, you know. Everything you see, you understand. And yeah, and now go into the C++ STL. It's complete chaos. It's like what the hell is going on here? It's total mess. I wonder if I have some, if you can access it actually in yeah. Type defs. What the hell is this? Class traits. Right, left, right. Okay. This almost makes sense. Operator. But look at this garbage. Yeah, let me go to a vector. Vector is fun. Vector is super fun. Let's find a vector somewhere. Texture parameters. Okay, this is not stats. Not that vector, no. Splat. Material. Let's go to material. Property. Type string. Vector. There it is, vector. And you're just like, what the hell? Unfancy maybe null. I love this. Okay. And then you want to go into like one of these functions. And what the hell is going on here? It's a forest of underscores. By right size. You're just completely lost here in this code. Let's see the code for in place back. It's fun. and place back. Look at this. Okay, what the hell is this? Walty, and then dot 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 has unused capacity. Okay, plus forwards. What is forward Walty class dot 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 in place reallocate. Okay. Yeah. This is, yeah, I don't understand what's going on here. Orphan range. My head hurts looking at this. Anyway, yeah. This is the best thing about, I can just go into Zig, bounded array. Everything makes sense. Even the complicated stuff. Slice. You get a slice. Wait. Okay, I'm confused. I didn't know you can switch. What? There's no return type here, which is interesting. There's no return type. Instead, there's a switch. What the hell is that? I didn't know that was possible. So you could switch on a type. I guess you can, instead of return type, you can switch on a type. And then this is the actual body of the function. Interesting. Huh. Cool. I didn't know you can have multiple return values. Like you can choose between return values, basically. Sorry, I don't mean to start a language war. My bad. Please ignore my last comment. Rust is also char vomit, though C++ is arguably better than both of Rust and Zig. Pfft. Okay. C++ is horrible. Have you seen the shit people do with templates there? You're probably right that C++ is usually less verbose, but it's been around a long time. Zig is still pre 1.0, so we at least have hope that it will improve. Yeah, I struggle with C++. It's really tough to follow lots of the time, but I don't really use much, so that explains most. How long, team, you work on this project? Of course, the STL is quite old and it has much more time to accumulate craft, but it's night and day when you compare this stuff with Zig's vector counterpart, std ArrayList. Yeah. The return type is a switch statement. Yeah. The return type is a switch statement. I didn't know that was possible, but that's kind of cool. I mean, also I don't. Yeah. One of the things I don't like in Zig is that you have to define a return type. There's no any type return type. It doesn't work if you put any type. So you always, yeah, I don't know if this is by design, so that because it kind of prevents a lot of overload problems then. But yeah, then you have these switch statements in return types. Okay. So let's temporarily switch to the differentiator, to textures. Okay. And I'm gonna, yeah, load two textures, and for the material, I'm gonna have I'm gonna assign two textures to them. Both textures, actually. Add property texture 2 is brick texture. And this is gonna be test text. Okay, so there we go. Let's try this. There was a runtime error. What does it say? Invalid uniform name. So, texture 2. Is that the name of it? Underscore texture 2. It is correct. What is going on here? What is going on here? Okay, let's see. Invalid uniform name. I should add some info here. Yeah, I have something here. No, those are just with, okay. Actually, can you safely output a, which is not a runtime error? Something like compile error, but at runtime. Like assert log. No, that's a logarithm. I guess I'm gonna have to use error. I know what the problem is. The problem is the lack of color. Problem. Well, let's see. Compiler cannot format slice without a specifier. Uniform by name of color doesn't exist. Yes, I knew it. I knew that was the problem because I'm adding a color and it doesn't compile. Okay, let's try this. std debug panic if you want to format it. I see. Okay, there we go. We have two textures that are blending. Are they? Are they? Yes, they are. Yes, it's a painting plus, you can barely see it, but it's a painting plus the brick on quads, on jittery quads. Cool. Okay, so it works. It totally works. Nice. Okay, so there's one thing I wonder what happens if you do it in different sequences. Is that going to mess up? Okay, let's make it like 0, 8, so that one texture is more visible than the other. Yeah, let's do Okay, so the brick is more visible than the painting, right? Yeah. Let's reverse the order of one type, because this is going to be unit 0 then. Oh yeah, but it's still, yeah, because I'm actually setting the unit to the uniform. So yeah, it is consistent. Good. It does actually work. Cool. Okay. What happened? Nothing happened. So what did I want? What did I want to do? Yeah. STD debug. STD debug panic. So, but is panic is not gonna return an error, right? It's actually gonna like, let's see. Oh yeah, let's actually trigger it with a color. What does it say? Panic. Uniform by name of color doesn't exist. So yeah, it doesn't return an error. Just panics. It instantly returns. But I would like to actually catch this error and prevent the panic. But if it does crash due to the error, if it does crash during the due to the error, it should panic. And there's also at panic. Okay, what's the difference? Panic handler function. By default, the panic handler function calls the public. Generally, it's better to use STD debug panic. However, panic can be useful for two scenarios. For a library called calling the programmer's panic function if they expose one in the root file. When mixing C and Z code, calling the canonical panic implementation across multiple O files. I'll keep it like this for now, even though I can't catch the error. To do, make it so I can handle this error and prevent the panic. I wonder if that's, yeah, how would you do that? Unless you put it outside. Okay, so anyway, that's about this. Oh yeah, let me actually I want to allow colors as well. Okay, let's make this into location is less than 0. 2 textures. Okay, let's 2 materials. 2 blending materials. So that's it. I've done that as well. It would be nice to, what was I saying? I was saying that if I added a color like this, yeah, it invokes a compile error. But I do actually want to add a color. Oh, color doesn't even exist. Oh, I forgot to add a comma. Okay. So taking in the color, and I want to actually cast it into a, so if color, then I'm gonna grab a color and I'm gonna set uniform by name, and I'm actually gonna redirect to color dot from vec, no, to vec4, right? Yeah, to vec4, that's the one I used. Okay. After prong, okay, I can do this actually without, there we go. And this is a function, of course. Okay, now we accept color properties, which is much nicer. But it should actually fail because I'm using a wrong, yeah, there it is. So I'm gonna use texture only again. Okay, another uniform by name of color doesn't exist. Oh. Yeah, not in texture only. And shapes. Yeah, let's go with frag. Back to frag. Back to frag. Okay, let's, yeah, and now we don't have a texture 2 anymore. I'm just testing with texture 1. Okay, everything works again. And let's add some nice UV'd items, and then I can end my stream. What is this? What did I do? Added color as a property. Okay. And what else did I want? Oh yeah, let's clean this up. I don't need to use random booleans anymore. I don't need to use the shader set matrix anymore either. For the camera projection matrix, also this set uniform 0. And these ones are no longer needed because now everything is handled with materials. Okay, so shader set uniform by name. Yeah, we need to pass the perspective perspective matrix and view matrix, and then yeah, this is where we're doing the motion and then rendering everything in a single, almost in a single line. Can you do this without yeah, you can. And this I can also remove. There it is. Okay, sphere, I'm gonna keep it. Let's remove this and data. Okay, yeah, one more thing that I wanted to add is I wanted to actually add, when I'm creating quads, I want to add them onto top of my vertices and not, yeah, append them so that you can add multiple quads. So like this. Instead of clearing, I'm gonna delete that, and the only thing I need to do is I'm appending vertices. That's good. But I also want, oh yeah, I should also make normals for quads. But yeah, I'll do it later. What I need to do here is I need to have indices which are, yeah, basically I need to have a beginning index, which is the number of vertices. Vertices count. Is there a len? No, I need to do items len. Is that the length of, I guess it is. And then everything is I plus, so like this. What's the problem now? Expected type U32, found U size. Okay. That's gonna be U32. And I'm gonna do an incast. Oh, cool. Nothing happens. Okay, so the vertices should be nothing. Doesn't change anything. This is weird. Wait, 0, 1, 2. Yeah. I changed nothing at all. Let's rename this to quad mesh. Do you need to move up above appends? All right, you're correct. It's such a simple thing to. Yeah, that's correct. Okay, makes sense. Right. Well, and the reason why I did this is so that you can like make multiple objects. You can just add. You could add another one if you so wish. For example, you move vertices. Like this. I don't know, I moved them by 2 meters sideways. And then I add another quad. So there's going to be 2 quads inside one. Okay, I'm always making mistakes when initializing this. Okay, yeah, let's do mathvec3 this way instead. All right, I can't add them. I need to do this. What the hell? Ah, a pointer. Okay, there it is. You have 2 identical sprites right next to each other. Cool. Okay, so yeah, adding more quads to a shape works. And that's how the cube, well, quad. This is how the sphere should also work. But it doesn't work right now. Try shapes sphere. Let's actually do this. Let's have a slightly smaller sphere. I don't need to render really high detail. But the thing is that I'm also not adding indices, right? I need to add them. So it's here. What is this? Okay. Let's remove these. And instead have capture is mesh indices items len, so that I can add it here later. Well, this should be a const. Should only add it to these two. What does it say? Yeah, and I also wanted to make it the EU32 and cast into it. White space on one side. Aha. Okay. So it is added now. Capture I shadows I. Cool. Nice. Let's call it V, vertex index. No, let's call it Venum. V count. Oh, and it's not indices, it's actually vertices. Okay, so I've created the sphere mesh, but I'm not actually using it. So let's just add some items. Oh, here's my sphere go. Sphere mesh test material. Yeah, let's use just the test material. And what about sphere go? Is it going to, okay. Yeah, let's keep the other sphere go as well. And we're gonna use sphere mesh for it, and yeah, two different materials. But since they don't have UVs, they're not gonna work anyway. There, we have two spheres within all these quads. The other sphere is somewhere inside. Not bad. Okay, cool. Everything seems to work. We can move on to some cooler things. Oh yeah, one more thing I wanted to do is optimize. Yeah, for example, sphere. when I'm creating the sphere, I have all these radial segments and stuff. And for circle points, okay, let me just add here cleanup, and shapes now append to the end of mesh. So yeah, first off, I want to rename this to circle points. Yeah, but then another thing that I want to do is yeah, instead of providing an array list here that will append new items, I should provide a slice instead. Because I already know that the slice is going to be pushed into. I already know what the size of it is going to be. So yeah, I'm gonna provide a slice. We have a problem. Yeah, you know what? For the beginning, I'm gonna do a slice points instead of explicitly having to go with array. Yeah, the problem here is that I actually need a vertex. Okay, so we're not going to have append. Instead, we're going to have for each of them I'm just going to assign it. Yeah. But for each of the sides, yeah, the thing is that if I already have points, I know that it's a slice. So, well, I can actually, I could do it at compile time. Check if the sides match points. No, I couldn't do that at compile time because I don't know what's going to happen at. If points len is not sides plus 1, I can just panic here. Okay, and now instead of having this buffer, I'm actually going to create a I'm going to have a bounded array because when I made this I didn't know about the bounded array. I used the fixed buffer allocator. So now I'm going to have a buffer is going to bounded array of math vec3 no, I mean vec3, and it's going to have a capacity of sides, the name, the capacity should be, oh yeah, well, I need some kind of a maximum. Yeah, in this case I use 256. But yeah, this could all be part, oh yeah. This could all be part, oh yeah, I can't do that because I need a slice of vectors. So instead of all this, yeah, I need to do this. And I'm basically providing a buffer slice yeah, but I need to allocate the right amount. Can I do a resize? A resize to sides red segments -1. No, +1. And then I take a buffer slice. And then I'm gonna add each of these to and then for each of these it's gonna be buffer items IV1 plus equals height. Yeah. No, but this is actually slice. Like this. Okay. Let's see if that works. If I didn't fuck something up. There it is. It works. Cool. Okay, so I think I'm gonna end it here. It's almost 4 a.m. here. And I'm gonna continue working on some, I don't know, what's actually the next thing to do. Okay, one more thing I did is clean up and optimize mesh, sphere mesh, and also shapes should append to end of mesh. Done and done. Okay, cool. Oh my god, STL. So there we go. We have some spheres, we have some cubes. We can render textures. Oh yeah, one more thing. There's one more thing. I wanted to go back to my frag, which uses frag color. Yeah, which uses lighting. Here we go. Let's see how lights work. Okay, well, quads are completely invisible. Spheres work. Quads are completely invisible because they're in the dark. And also they don't have any... yeah, actually the problem is that they don't have normals. So let's add the normals. I'm gonna add here norm is math vec3 and it's gonna be 001, I think. I don't know if it should be the forward or the backwards, and you never know that. Dot normal is norm. Okay, still nothing. Let's flip. Okay, we have some lighting now. It's a little bit too bright. Oh my god, my eyes hurt from this. This is some weird optical illusion, actually. My eyes really hurt from looking at these colors. But they don't have any texture, which is what I'm alarmed about. So I have text. Oh, I'm not actually even using it. Okay, so this is gonna be text by text RGB. There we go. We have some textures. Actually, it's the same texture for both. Did I make a copy-paste mistake again? I did. This should be a brick. Okay, let's actually pass white so that we just have pure textures. There we go. Nice. Okay, can I add some UVs to the spheres? Let's see. Is it possible to add UVs to the spheres or not? Radial segments. Okay, yes, I think I can. from radial segments. Yeah, basically it's gonna be okay, const u is I divided by rad segments. Float from int. What does it say? Must have a known results type. Okay, yeah. I should have just converted to float 32 instead. Oh, this is text v. Let's go with text u. Instead. Okay, now the spheres have textures as well. Nice. Let's see. Let's actually not make these quads. And let's not jitter. Nice. We have some balls with textures. Looking nice. And yeah, this definitely should be +1. Okay. Oh yeah, I can actually init to the size this. Set the actual length of the slide. Return arrow if it exceeds the length. Add sex plus 1. Yeah, I don't need to resize it. I think this is what it means. Ah! It's because it needs to try. There we go. Cool. Do I have a checker pattern? Common. Oh, I actually have a UV checker. Yeah, I should have used this one. Oh, I made a mistake. I should have put large ls. What's the name of it? Large git thing. LFS. I'm gonna do that tomorrow. Let's use a UV checker instead. Instead of the brick, UV checker. Okay, so one of these has a UV checker. There it is. Nice. Not bad. Not bad. Okay. So next thing I need to do spheres with UVs. And a UV. Yeah, let's use git lfs. I need to remember how that works. Git attributes, right? Okay, now this is going to work with LFS, yeah. UV checker. Push. Okay, so I think this is pretty much it for today. There it is. Zig down, latest commit happened now, as it says. Added UV checker quads with normal spheres, UVs. Better shape gen. Oh, I should add to my readme. I need to add STB image. Has there been any changes to STB image 8 months ago? Add version history. Let's see what the history of it is. I should say that this is the link to it. For texture loading, okay, anything else? To build, simply run zig build run. With a smiley. No. Let's add this as a caption. Building. Okay, no, there's nothing. How to build. All right. And that's pretty much it. Made entirely in stream. How to build. Simply run zig build run. That's it. That's pretty much it. Oh, it's 60% zig, 40% C. And that's just because of STBI. Interesting. Okay. Yeah, and I pretty much think that that's it. I've done a lot of things today. Most of it concerning texture loading, as well as creating abstractions, creating materials. Oh yeah, let's see what I've done so far in my map. Okay, let's move this down. What is this? I don't know. Okay, so bounds, transform, material is now done. And properties are now done. Oh yeah, I think material properties took most of the time to figure out how to create unions at runtime. Transform is done. The only thing that's to be done are bounds now for mesh making. So yeah, that is something that is left to do for tomorrow. No, not tomorrow. Maybe not tomorrow. I don't know. Maybe some other time. So basically, frustum culling. Yeah. That would be relatively easy to add, actually. It's just a simple check and a simple, yeah. Relatively simple, yeah. That shouldn't be, that's much less difficult than dealing with OpenGL stuff. Okay, so how does my main look like now? So many redirects. I use a single GPA for my meshes, quad, shapes, brick texture, I'll create the material, add some colors, textures, and then that's it. I create a scene, add 2 objects, and I add 200 quads optionally. And then I have, okay, this is just garbage. Color in it. Yeah, this was just a test. And then I have some, oh yeah, by the way, I added delta time. I added this off stream. I'm just comparing to last frame times from glfw get time. Engine input key pressed, WSAD CX for moving the update. Yeah, probably I should remove this. And then setting the wireframe, binding the shader. Oh yeah, this shader bind is no longer needed, by the way. But yeah, you need to set the uniform. And that's the problem. And to set the uniform, you need to bind the shader. So this should actually be moved into rendering. Let's see if this works without binding the shader. It still actually works. So I guess when it comes to global stuff, it's not needed. Okay. Yeah, I'm gonna end here. Thanks for joining. Thanks for joining again in my Zig adventure. There's quite a lot of things to do if I want to add feature parity. Yeah, I think the next time I'm gonna add bounds. And I want to add some sort of model reading. So GLTF, if I can find some GLTF loading, that would be amazing for Zig, so that I can load GLTF files into my game instead of like procedurally generating stuff. Yeah, nice. Okay, well, see you some other time. I don't know if it's going to be tomorrow, maybe, but I'll see. This is my C++ engine, by the way. Matrix utilities. Yeah, there's a lot of things that I don't actually need. Oh, look at this, STD unreachable. Yeah, I am pretty satisfied with how this is going. So the engine now has 600 lines. Pretty good. Not that bad. Although I am decomposing here in the 10 lines. Text image 2D. Shader. Mesh. Oh yeah. This maybe I can remove. Camera. Yeah, I definitely need to add positions into transform and everything so I can edit position directly. Instead of relying on the transform, on the matrix. All right. Well, that's it. Let's look at the beautiful spheres one more time. And then I'm gonna say goodbye. There they are, in all their glory, with a beautiful UV checker. and some simple Lambertian lighting, as they would say. Okay, yeah, see you some other time. Thanks for being here, much appreciated. See you soon.